To graph this piecewise function here that is defined by three separate functions, we first want to start off by annotating our graph and determining our function values at these edges of our domain. So when x equals -3 and where x equals 1, our function is going to switch from one function to a different function. So to organize our graph, we're going to start off by defining the function at these specific points. So let's first look at our first function, 3x plus 8. We know our function is going to be equal to 3x plus 8 for any value that is less than -3. So let's go ahead and let's evaluate this function when x equals -3. So to do so, we are going to substitute -3 in for x. 3 times -3 gives us -9. When we add 8, that is going to give us -1. But if we look at the domain here, we know that x is less than -3. That is our domain for this first function here. So when x is equal to -3, we are not using this first formula because we don't have x is less than or equal to -3. We just have x is less than -3. So the way we are going to show this on our graph is with an open circle. So when x equals -3, for this first function here, f of x equals -1. But we are going to represent that with an open circle because our function is not necessarily defined at this point because it is not included in the domain of our first function. But because the function 3x plus 8 is defined for any x value less than -3, we can go ahead and we can graph the rest of this function. It's a linear function with a slope of 3. So if we plot a few other points, we can get our linear function graphed. So all I did is I used a rise over run of 3 over 1 because our slope is 3 to graph the rest of this linear function. And because it's a polynomial, it's going to be continuous on the rest of the domain where x is less than -3. So we have successfully graphed our first function. Let's move on to our second function, which is defined on the domain between -3 and 1. So let's go ahead and let's evaluate this function at f equals -3. So to do so, we are going to substitute -3 in for x. And so that's going to give us f of -3 is equal to 6. So we can go ahead and we can graph this point on our coordinate plane. And -3 is less than or equal to x on this domain. So this point is going to be included in our graph. So if we find f equals -3, we can go up and plot f of -3 is equal to 6. Now let's look at the other domain restriction here. For our second function, the domain is -3 less than or equal to x less than 1. So let's do the same thing. Let's find f of 1. So we're going to substitute 1 in for x in this second equation here, giving us f of 1 is equal to -2. So we can go ahead and when x equals 1, f of x equals -2. So let's graph that on our coordinate plane here. But again, we want to use an open circle because when we look at our domain, we see x is less than 1. We don't have that less than or equal to 1 sign. So this function is not defined. -2x is not defined at x equals 1. Because this is another linear function, we can just go ahead and connect these two dots because anytime you know 2 points on a coordinate plane and we have a linear function, we can just connect those dots. Okay, so now we have one more function to evaluate here, to plot on our coordinate plane. We have x squared minus 3. So x squared minus 3 is included on the domain where x is greater than or equal to 1. So let's go ahead and let's evaluate this function at 1. So to do so, we are going to substitute 1 in for x, and that's going to give us 1 squared minus 3. F of 1 is equal to 1 minus 3, or negative 2. Because this function x squared minus 3 is defined on our domain for any value of x that is greater than or equal to 1, this point here, f of 1, is defined on this function here for x squared minus 3. And this just so happens to be the same point where we have evaluated f of 1 for our second function. So let's go ahead and fill this circle in, because we know that our function is defined at f of 1. This third function is not a linear function, it is a quadratic function. So to accurately graph it, let's find one more value of x to substitute into this equation, this function, so we can get an accurate sketch of our graph. So we can choose any x value that is greater than 1. So let's go ahead and let's just evaluate this function at x equals 2. So we're going to substitute 2 in for x, leaving us with 2 squared minus 3. 2 squared gives us 4 minus 3. So f of 2 is equal to 1. Let's go ahead and let's plot that on our graph here. So when x equals 2, f of x equals 1. And so now that we have found another point and we know the general shape of our function here, it's a quadratic function, it's going to be a parabola, we can go ahead and we can sketch in this piece of our function. So we know we're going to have a parabola, a quadratic function, when x is greater than or equal to 1. So this is how we can graph a piecewise function on our coordinate plane.